Welcome to the Curious Calculator. In today's video, we're going to be going over solving logarithmic equations. And to do this, we're going to be utilizing the property of equality for logarithmic equations, which is stated as follows. Log base b of x equals log base b of y if and only if x equals y. And we have the restrictions that b, x, and y must be greater than 0, and b cannot equal 1. Now I have a few different examples lined up here with each of them increasing in difficulty. So let's go ahead and get started with those. The first one I want to look at is log of 5x equals log of 2x plus 9. Notice here that we do not have the bases written next to the logarithms, and when that is the case, the base is always going to be 10 because this is known as the common logarithm. So because the bases are the same, we can go ahead and equate these two expressions. 5x equals 2x plus 9. Now subtracting 2x from both sides, we have 3x equals 9. And dividing both sides by 3, we have x equals 3. And that's going to be our final answer for that one. Let's go ahead and look at the next one here. We have 2 log base 7 of negative 2r equals 0. To begin this one, let's go ahead and divide both sides by 2. So we have log base 7 of negative 2r equals 0. And now we want to have both sides of these equation have logarithms with base 7. So let's go ahead and start that. So we have log base 7 of negative 2r equals log base 7, and we need to figure out what we can put in here. Well, we can look up right here, and we need to put in here what 7 raised to 0 is. And 7 raised to 0 is 1. And we can check this. So log base 7 of 1, well, that's the number that we need to raise 7 to get 1, which of course is going to be 0. And now that we have logarithms with the same base on both sides, we can go ahead and equate these two expressions. So negative 2r equals 1. And now dividing both sides by negative 2, we have r equals negative 1/2. And that will be the answer for that one. Now let's go ahead to the next one here. We have negative 2 log base 5 of 7x equals 2. Let's go ahead and divide this negative 2 on both sides. So we're left with log base 5 of 7x equals, well, 2 divided by negative 2 is going to be negative 1. And we want to do the same thing here. We want to have logarithms on both sides with the same base. So we can go ahead and write our log base 5 of 7x equals log base 5. And we need to figure out what goes in here. Well, what's going to go in here is what 5 raised to the negative 1 is. And 5 raised to the negative 1 is going to be 1/5. And we can check that. So the answer to log base 5 of 1/5 is the number we need to raise 5 to get 1/5, which of course here again is going to be negative 1. And so now we can equate these two expressions. We have 7x equals 1/5. And so x, dividing that 7 on both sides, x equals 1/35. And let's see here. I have another one lined up here. We got log of x plus log of 7 equals log of 37. So in order to solve this one, we're going to want to combine these together. And remember that when we add logarithms, we're going to multiply these two expressions here. So we have log of 7x, right? We're multiplying those two expressions together. And then we have log of 7x equals log of 37. And at this point, we have two logarithms with the same base, and so we can go ahead and equate these two expressions here, 7x and 37. And so we have 7x equals 37. X equals, dividing 7 on both sides, 37 over 7. And let's see here. I have one final example lined up here, and that is going to be ln of 4x plus 1 minus ln of 3 equals 5. So again, we want to bring these two together, and whenever we are subtracting rather than multiplying the two expressions in here, we're going to be dividing. And so we have ln of 4x plus 1 divided by 3 equals, we're going to leave the 5 here. And now at this point, we want to do a similar thing to what we were doing before. We want both of these, both sides of the equation to have logarithms with the same base. And remember here that ln is the logarithm with a base of e. And so we're just going to do the same thing we were doing earlier. So we have ln of 4x plus 1 over 3 equals, well, ln, or log base e. And then we need to figure out what goes in here. And so what goes in here is going to be, well, we need to raise e to the 5th power. And so we can just go ahead and write that in here, e to the 5th power. And to check this out, so we have a log of base e, and that is of e to the 5th power. So it's going to be the number that we need to raise e to equal e to the 5. Well, that's just going to be 5. So that checks out. So now we can equate these two expressions here. So we have 4x plus 1 over 3 equals e to the 5. And now solving this, we can multiply both sides by 3. We have 4x plus 1 equals 3e to the 5. Now subtracting 1 from both sides, 4x equals 3e to the 5th power minus 1. And dividing 4 on both sides, we have x equals 3e to the 5th power minus 1 over 4. And that is going to be our final answer for that one. And that's going to be the end of today's video. I'd like to just end with a fun fact from philosophy. Did you know that the Greek philosopher Thales of Miletus, who is the first Greek philosopher that we have recorded history of, he argued that the fundamental substance of nature is water, meaning that among all the different things, such as dirt, animals, plants, that if we could strip them down to what they are most fundamentally composed of, in each case, the result would be water. If you enjoy this content, please be sure to like and subscribe. That really helps out.